Hey everybody, Mrs. Bixler, we're back again. You're probably still reeling from law of sines, but don't worry. The law of cosines, which we're going to learn about today, is kind of crazy, but it's a little bit simpler, so don't worry. So let's talk about the law of sines quickly, just to review. So we use law of sines in two situations. And those two situations were angle, angle, side, and side, side, angle. And remember, side, side angle was a pain in the side, side angle. I could get 1, 2, or 0 triangles. Angle, angle, side, I only could get one triangle, right? As we know and feel comfortable with. All right, fabulous. So now, what if we're given a situation that looks like this? So neither of these are side, side angle or angle, angle, side. This on the left is a SAS situation. And this over here is a side, side, side situation. So this is where law of cosines comes in. Now, if you remember, and you should, side angle side and side 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 were two of our congruence triangle postulates. And so we knew with those parameters, we could only get one triangle. So that is the glorious part of the law of cosines. You are only going to get one triangle with the law of cosines, only one triangle. So you don't have to test, you don't have to worry about any of that stuff that you had to do in the side-side angle situation with the law of cosines. So let's look at the law of cosines. It looks terrifying, but I promise it's super straightforward. So here's the law of cosines. It tells you that the side length squared and the cosine of the opposite angle have this relationship. So this is the relationship. So we've got a side length squared, and it equals the other two sides squared minus twice times those other two sides. Now, it doesn't always have to be side C. I could have a situation where I've got side A. And in that situation, I would have A squared equals B squared plus C squared minus 2BC times the cosine of A. The important part here is that this guy and this guy match up. And this is also all multiplication. Remember that, too. So this is the law of cosines. Make sure that you have this written down, and you can keep referencing it as we work through the problems. So let's do this situation first. Again, a lot of blue boxes, totally fine. But this is a side angle side situation, right? A SAS, we're super comfortable with it. I want you to pause the video, and I want you to try this on your own. And I want you to try to solve for side C. Go. All right, we're back. So hopefully your setup here looked like this. So you've got side C squared equals 7 squared plus 5 squared minus 2 times 7 times 5, right? These are the other two sides, times the cosine of 40. C squared and 40 degrees are opposite each other in this triangle. Cool? So hopefully you felt really good about that. And when you did this out on your calculator, following the rules of PEMDAS, do not forget to follow the rules of PEMDAS. That means, my loves, that this all goes together. This is all multiplication. It is not going to be 49 plus 25 minus 2 times 7 times 5, and do that, and then multiply by cosine of 40. You need to make sure that you do this sucker all together. All right, so hopefully you got for side C, you got, drumroll please, approximately 4.51. All right, I have great news. Look what happens when you solve for that missing side. You now have a ratio. So you can now use the law of sines. Amazing! So we now can use the law of sines, which we love, and it's so easy and wonderful. So I would start off with the sine of 40 degrees over 4.51. And it's not ideal, right? We're rounding here, but that's okay. And that's going to equal. Now here is where I have a choice. So this is what you have to remember. With law of sines, you are always going to go small. So you are going to start with the smallest angle or the smallest side. So right now, do you see how 5 is less than 7? we're going to solve for angle B next. So the next thing we're going to do is say the sine of B over 5. Then you cross multiply and solve, and then you should get that B is approximately, again, 45.45 degrees. And then, looky-loo, you don't have to do the law of sines again. You can just do 180 minus or 40 plus 45.45, and you get angle A, which is 94.55 degrees. And again, this is all approximating because we approximated first with that side C. So again, law of cosine seems really intimidating, like this C squared equals A squared plus B squared, blah, blah, blah. But you only have to do it once, and then you're back to law of sines. And then you just have to do 180 minus something, which is like kind of nice. So that's a side angle side situation. Now let's look at a side situation. Again, a lot of blue boxes, apologies. But remember for law of sines, if you had a choice, you went small. For law of cosines, you always are going to go big. You're going to go colossal. So law of sines, small, cosines, colossal. So here, do you see how side length 8 is larger than 6 and 4? That means we're going to solve for B first. So I want you to pause the video and I want you to try and solve for B. Go. All right, we're back. So hopefully your setup looked like this. So 8 squared equals 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of B. Now this is messy, so I'm going to show you exactly the steps that I walked through. So here I subtracted 52 from both sides. I got 52 because I did 6 squared plus 4 squared. And then remember, because of PEMDAS, all this stuff has to stay together. The worst thing you can do is get 52 and then do minus 2 times 6 times 4, and then keep all that together and then multiply that times cosine of B. That's the worst thing you can do ever. So you don't want to do that. So then we subtract 52, and then you get 48 times the cosine of B. Then you divide by 48, and then you wind up having to do the inverse, remember? So it would be cosine inverse of negative 0.25, and that would give you approximately what B is, which is 104, there you go, 104.48 degrees. And then your next step would be the law of sines, because look, you've got a nice little ratio here. So you would do the sine of 104.48 over 8. But then remember, law of sines, you have to go small. So which angle measurement are you going to solve for? A, because 4 is the smallest side that's left. So hopefully that makes sense. You are going to crush the homework, and I will see you all soon. We've got this. We're going to do a lot of practice, and this is going to be great. I'll see you soon. Thanks.